Okay, so in this video we'll be looking at adding, subtracting, multiplying, dividing complex numbers. So first of all, we'll be looking at dividing a complex number by a real number. Now in this case, I've just chosen z1 is equal to 2 plus 4i as a simple example. What if I wanted a half of z1? Well, I would divide both sides by 2. And dividing by a real number is really easy. I just do the real part divided by the bottom line and the imaginary part divided by the bottom line. So 2 divided by 2 is 1 and 4 divided by 2 is 2. Now, we don't worry if fractions come out. So example, I have z2 is equal to 3 plus 5i here. And I'm going to divide it by 7 to get 1/7 of z2. So 1/7 of z2. Well, 3 divided by 7 doesn't go in evenly, but that's okay to have 3/7. And 5 divided by 7 is 5/7. It's okay. That's fine having fractions there because 3/7 and 5/7 are real numbers, so that's fine. Okay, so then a conjugate. So we know a complex number generally looks like a plus bi, where a and b are real numbers. So it could look like 3 plus 4i, or 5 minus 2i, or 1 over 2 plus 3 over 4i. That's 1 over 2, and the way I can tell it's 1 over 2 is because it doesn't have the line through it, not 1 over z. So if we change the sign of just the imaginary part, we call this the conjugate of the complex numbers, of the complex number. This is shown by z1 bar, and that line across the top of the letter is bar. Okay, so we call this z1 bar, or the conjugate of z1. So, for example, the conjugate of z1 here would be 3 minus 4i, or 5 plus 2i, or half minus 3 over 4i. The sign of the imaginary part is changed, not the sign of the real part. That's the only bit that changes, is the imaginary part. So, for example, then, the conjugate of all of these, given that z is equal, given z, find the z conjugate, or z bar, in each of the following. The only part that's different is the imaginary part. The imaginary part changes sign, the imaginary part changes sign, and what would this be? It would be z bar is equal to minus 5 minus I. Okay, so multiplying fractions then. What do we end up with? Or not multiplying fractions, excuse me, multiplying complex numbers. So I have two complex numbers here being multiplied together, two brackets. Look, it's exactly the same as before, as if it was algebra. We split the first bracket in two, and then we multiply it by the second bracket, and we split the second bracket, split the first bracket. So it's going to be 4 by the second bracket, and then I times the second bracket. 4 times 3 is 12, 4 times minus 5 is minus 20, and we have the I. Now I times 3 is 3i, plus by minus is minus, 1 by 5 is 5, I by I is I squared. I by I is I squared, but what do I know about I squared? I squared is equal to minus 1, so this is really minus 5 by minus 1. Minus 5 by minus 1 is 5. So it's 12 plus 5 is 17. Similarly over here then, we're going 5 by 3 is 15. 5 by minus 5i is minus 25i. Minus 2i by 3 is minus 6i. Minus by minus is plus. 2 by 5 is 10. I by I is I squared. What do I know about I squared? It's minus 1. So I'm getting 15 minus 10. So that's 5. And then I have the minus 31i, which is missing here. It's minus 31i. That's missing right there. So all of this is quite important then in multiplying a complex number. So how do you multiply a complex number by its conjugate? Now, something curious happens when we multiply a complex number by its conjugate. So if I chose any complex number, you can watch this example, then make up any complex number, and you'll see the exact same thing happen. So I've chosen 3 plus 4i, and I'm going to find its conjugate, and watch what happens when I multiply a complex number by its conjugate. So it's 3 plus 4i by 3 minus 4i. 3 by 3 is 9. 3 by minus 4i it should be minus 12i, but I have that there. 4i by 3 is 12i. Plus by minus is minus. 4 by 4 is 16. I by I is I squared. When you're multiplying by a complex number by its conjugate, you will always find the middle section will cancel. And we get minus, well, what's I squared? I squared is minus 1, isn't it? I squared is minus 1, so this is really plus 16. Plus 16. Similarly, another example. If I'd chosen 5 minus 2i as my complex number, the conjugate of it would be 5 plus 2i. 5 by 5 is 25. 5 by 2i is 10i. Minus 2i by 5 is minus 10i. Minus by plus is minus. 2 by 2 is 4. I by I is I squared. I know I squared is equal to minus 1. So it's minus 4 by minus 1 is plus 4, and I get 29. The exact same thing happens here with the fractions. How do we multiply fractions? Top by top, bottom by bottom. So a half by a half is a quarter. A half by 3/4 is 3/8. 3/4 by a half is 3/8. And then 3/4 by 3/4 is 9/16. Okay, all multiplying top by top, bottom by bottom. How do we multiply fractions? We will come along to that again. All of that simplifies down. When multiplying a complex number by its conjugate, you end up not having an I part. Now there's a shortcut to that. There is a rule that you can learn, and it's here. That if you had a complex number, which is a plus bi, and then its conjugate was a minus bi, what always happens, you will always get a squared plus b squared. That always happens. So a complex number by its conjugate is always a squared plus b squared. And it doesn't matter then. So if I said, if it was 5 minus 3i, and I'm multiplying that by 5 plus 3i, it's always 25 plus minus 3 squared. 25 plus 9. Doesn't matter if I'd chosen this to be b or this to be b, because it'll always end up being a plus. Okay, so where is that useful and why do we have that? So we've looked at adding complex numbers. When adding complex numbers, we just add like terms. So like with like, so the real parts with the real parts, the imaginary parts with the imaginary parts. But now we've already looked at multiplying complex numbers as just multiplying out like normal brackets. You just need to be careful with the I squared that it's minus 1. We've looked at dividing a complex number by a real number, which is just the real number dividing into the real part and the real number dividing into the imaginary part. Now we need to look at a complex number divided by a complex number. So, complex number divided by a complex number. Right here, I have a complex number divided by a complex number. So I'm saying Z3 is this number here. It's 2 plus 3i divided by 4 minus I. So this is a fraction. We can't multiply or divide it by anything without fundamentally changing it. For example, you couldn't multiply a half by anything. You couldn't multiply it by 3 because then you would end up with 3 halves and it would be fundamentally changed. 4 over 9 is not equal to 4 over 9 times 7. There is one number I could multiply this by. There's one number I could multiply it by. It's the most versatile number to multiply by. I could multiply by 1. Okay? You can multiply anything by 1 and it will remain the same. So it's a really versatile number. I'm not able to divide this. It is not 2 over 4, 3 over minus 1. It is not that. It can't be that simple. So it's important to note that we can always multiply by 1. So Z3 is equal to 2 plus 3i over 4 minus I. The real problem with this is the fact that we have a complex number on the bottom line. We want to get rid of that legally. So how can we legally get rid of the fact there is an I on the bottom line? The only thing I can multiply by is 1. Can only multiply it by 1. But as I've said before, 1 is the most versatile number because it could be written as 7 over 7, 2 over 3, couldn't be written as 2 over 3, it could be written as 2 over 2, x over x. It can be written as anything over itself. So the question is, what could I multiply the bottom line by to get rid of the I? So the rule then that you really need to learn for this is to, when dividing a complex over a complex, or when we have a complex over a complex, multiply the top and the bottom line by the conjugate of the bottom. So watch what happens. Multiply top and bottom by the conjugate of the bottom. The conjugate of the bottom line here is 4 plus I. What do I know about 4 plus I over 4 plus I? It is 1, so I'm okay with that. How do I multiply fractions? Top by top, bottom by bottom. How do I multiply brackets out in complex numbers? Same way I do it in algebra. All I need to be careful of is the fact that this is not plus 3i squared. I need to remember that I squared is minus 1. So this really is minus 3. So what's 8 minus 3 is 5. 2i plus 12i is 14i. And look at what happens on the bottom line. It's a complex number by its conjugate. So I know that's going to be a squared plus b squared. A squared, it would be 4 squared, which would be 16. And then b squared would be 4 squared plus minus 1 squared. 16 plus 1, which would be 17. 8 minus 3 is 5, all over 17. Okay, well that's fine. Just write it as 5 over 17 plus 14 over 17. And I'm happy out. That's it, done. Complex divided by complex. Okay, another example for you. So I want to write this in the form of a plus bi. So it's basically saying just simplify this as much as possible. The only thing I can multiply by is 1. But I know that 1 is the same as anything over itself. Need to remember, multiply the top and the bottom by the conjugate of the bottom. So the conjugate of the bottom is 2 plus 5i. So it's 2 plus 5i over 2 plus 5i. How do you multiply fractions? Top by top, bottom by bottom. So it's 3 by 2, which would be 6. 3 by 5, which would be 15i. 4i by 2, which would be 8i. Plus by plus is minus. 4 by 5 is 20. I by I is I squared. And the bottom. What do I know about multiplying the bottom? It's a complex number by its conjugate. So I'm going to use a squared plus b squared. Okay, so top by top, bottom by bottom, fine. Multiplying out the top, the bottom, a squared plus b squared. Yeah, so this is just an explanation of what was earlier in the green box above. Green box above. Or earlier in the video, if you don't have this file. 15i. 15i plus 8i is 23i. Do I know about I squared? I squared is really minus 1, so that's where the minus 20 comes from. 6 minus 20 is minus 14, so I'm getting minus 14 plus 23i over 29. Okay, fine, just go minus 14 over 29, 23 over 29. Job done. A, in this case, is going to be minus 14 over 29. B is 23 over 29. Question done. Okay, so there's a trait of complex numbers that say if two complex numbers are equal, so for example, if I had a plus b, I is equal to 7 plus 3i, then I know as they're equal, a is equal to 7 and b is equal to 3. The real parts, which would be the pink parts, must be equal, and the imaginary parts, which are the green parts, must be equal. So find x and y if x plus 2i plus 2 by 3 minus 5yi is equal to 8 minus 13i. Okay, first thing jumping out at us is probably multiply this out. So two complex numbers are equal, then reals equals to reals, imaginaries equals to imaginaries. So started multiplying it out. 2 by 3 is 6. 2 by minus 5yi is minus 10yi. Okay, well then I can also group things together. The reason I can group the x and the 6 together is because they do not have any imaginary parts. I can group, or any i's with them. I can group the 2i and the minus 10yi together, which brings us down to this purple section here. What can I factorize out? I can factorize out the I. So then this part here does not have an I with it. So it must equal to the other side that does not have an I with it. This side here does have an I, and it is the imaginary part, so it must equal to the imaginary part over here. So now I get x plus 6 is equal to 8, so x is equal to 2. 2 minus 10y is equal to minus 13. And then we get y is equal to 3 over 2. Question done. Okay, so the questions do progressively get harder. We want to find, so given that z plus 1 is equal to 2 minus I is equal to 3 minus 4i, z plus 1 by 2 minus I is equal to 3 minus 4i. Find z. So let's get z on its own. Get z on its own. The first thing we should consider is we want to get this bracket on its own. So it really reads this bracket multiplied by this bracket. Okay, well, how do I get rid of two brackets being beside each other like that? Well, what does it mean? It means they are multiplied together. The opposite of multiplication is division. So divide both sides by 2 plus I. Sorry, 2 minus I, excuse me. So divide this side by 2 minus I. The 2 minus I and the 2 minus I cancel. And I get a complex number over a complex number. Well, fantastic. Complex number over a complex number. I know how to deal with that. I'm going to multiply top and bottom by the conjugate of the bottom. So the bottom in this case is 2 minus I. The conjugate of that would be 2 plus I. We've already learned a shortcut of how to multiply a complex number by its conjugate. It's a squared plus b squared. So a in this case is 2. B is minus 1. 2 squared is 4. Minus 1 squared is, so it's 2 squared plus minus 1 squared, and we'll get 5 out of that. Bit of rough work. And the top lines we need to multiply together as well. So how do we multiply the top lines together? Bit of color would be useful. 3 by 2 is 6. 3 by... That's wrong, isn't it? It is 3 by I is not 6i, it is 3i. So this is a 3i. Here. 3 by I is 3i. Minus 4i by 2 is minus 8i. And minus 4i by I is minus 4i squared. And what do I know about that I squared? It's minus 1, so this is really going to change to plus 4. 4 plus 6, nicely, is 10. And what happens here in the middle then? I'm getting 3 minus 8i, so I'm getting minus 5i out of that. Adding 6 and 4 to get our 10 on the top line. And we have our 5 on the bottom line. 5 into 10 goes 2 times. 5 into minus 5 goes minus 1. So I'm getting 2 minus 1i. 2 minus 1i. But I want to get z on its own, not z plus 1. So subtract 1 from both sides. Subtract 1 from both sides. Do I subtract these two? Well, no, because this doesn't have an I with it. So it ends up being 2 minus 1 minus 2 minus 1, which would be 1. So we get 1 minus 1i. Okay, so just 2 more questions for this video then. So the questions do progress quite a bit in this topic. So if you look here, we want to find x and y. So I know x plus y squared is equal to x minus 6i. So first thing that seems natural to do would be to multiply out that bracket. Okay, be careful, x by x is x squared. X by y would be xyi, and then iy by x would be xyi. So you have 2 of them now, so you've got 2xyi. Plus by plus is plus, I by I is I squared, y by y is y squared. What do I know about this section right here then? Well, I squared is equal to minus 1. So it's really important that we remember that. I squared is equal to minus 1. So that brings us down to this bit right here ends up being minus y squared. Well, the reason I have this highlighted in red then, the reason I have this highlighted in red is because it does not have any i's, whereas this section with the blue does have i's. So the red bit is the real part and the blue bit is the imaginary part. So reals must equal reals and imaginaries must equal to imaginaries. So looking at this, I have one equation with two unknowns and another equation with two unknowns. Now it's no longer complex numbers. Now it's just algebra. And it goes back to the start of the year before Christmas, that you should be able to solve this then. So you have a linear equation here from equation 1, equation 2. This is a linear and this is a non-linear. So the method that we use is to isolate a variable in the linear. Isolate a variable here. It doesn't matter if you isolate x or isolate y. I have decided to isolate y. So I've isolated the variable and I sub it back into the non-linear. So sub it back into the non-linear in here. Okay. My fractions being squared, how do we deal with that? Fractions being squared? Well, we'd square the top and square the bottom because it's essentially top by top, bottom by bottom. So minus 3 by minus 3 is 9. X by x is x squared, coming from here to here. Okay, well, if I were to multiply and get rid of the fraction here, it's going to look a bit nasty. The reason being, I would get an x to the power of 4, and I don't really like that. So I'm going to use a bit of substitution then and say, oh sure, look, let u equals x squared for the time being. So u minus 9 over u is equal to 8. Multiply everything by u, and I get a quadratic equation in terms of u. Okay, brilliant. Solve that for u. So either u is equal to 9 or u is equal to minus 1. Well, what have I said u is? U is equal to x squared. U is equal to x squared. So I'm going to remove this red for a second. So either, hold on. So either x squared is equal to 9 or x squared is equal to minus 1. But that would mean that x is equal to the square root of minus 1 and then x is equal to I. The reason this can't work for us and doesn't work is because x, this bit, cannot be imaginary. Remember, a complex number is x plus yi, where x and y are elements of the real numbers. If x was I, then x would be an imaginary number and it all falls apart. So this doesn't hold true, that x and y must be real. So we're only left with x is equal to the square root of 9. Well, what do I know about the square root of 9? There are two values. It's either 3 or minus 3. Okay, so great, brilliant. I have x. It's either 3 or minus 3. So then I can sub this back in for y and find the two values of y. So y is either minus 1 or 1, which then leaves us with our two values, our two complex numbers, 3 minus 1i or minus 3 plus I. Long question. But once you get to here, it's not really complex numbers anymore. It's just algebra until you get to here and need to know that x cannot be I. Okay, so one more question before we finish up. Okay, and let's look at this one. Okay, so I know that this is equal to 3 plus 4i, but z is a plus or minus bi. Okay, so let's not panic. Let's just set a plus bi is equal to square root of 3 plus 4i. Okay, well, what do I not like at this point? I don't like the square root. How do you get rid of square roots? Square both sides. A plus bi squared is equal to 3 plus 4i. Square this out. A plus bi is equal to 3 plus 4i. A by a is a squared plus abi plus abi plus b squared I squared is equal to 3 plus 4i. Okay, well, group the things that have i's and what don't have i's. So a squared plus 2abi minus b squared. Where's that minus b squared coming from? It's coming from the fact that I squared is equal to minus 1. Okay. Equivalent to... So we're going a squared minus b squared plus 2abi is equal to 3 plus 4i. I'm missing... What am I missing? A squared plus abi here. Let's just delete it. Okay, well, match like with like. I know they're the real parts and the imaginary parts. So what do I have? I have equation 1, which is a squared minus b squared. Okay, well, that's non-linear. 2 is 2ab is equal to 4. Okay, brilliant, a linear. Let's isolate a variable. Doesn't matter what variable I'm going to isolate. It can be a or b. So I'm going to isolate a. So get a on its own. So a is equal to, well, even I can take my time. ab is equal to 2. A is equal to 2 over b. Take our time and sub that in to the non-linear. So I'm getting 2 over b squared minus b squared is equal to 3. How do I square fractions? Well, it's multiplying it by itself. So I'm getting 4 over b squared minus b squared is equal to 3. Okay, brilliant. But if I was to multiply everything by b now, I would have a b to the power of 4. So let b squared equals to u. 4 over u minus u is equal to 3. Equals to 3. That's 4 minus u squared is equal to 3u. Okay, we've got a quadratic out of this. 3u squared. No, it's not 3u squared. It's u squared minus 3u minus, that's a y, minus 4 is equal to 0. Okay, factorize the quadratic. U minus 4, u plus 1 is equal to 0. So u is equal to 4 or u is equal to minus 1. We're not trying to solve this for u. We've used u. I've used u to find b squared. So b squared is either equal to 4 or b squared is equal to minus 1. B is equal to square root of minus 1. Well, what do I know about b? B must be a real number. Must be a real number. So, ignore this. As I've said before, we have now introduced a square root. When you introduce a square root, you must take the two values. So it could be plus or minus 2. Okay, brilliant. I have b, but does that help me find a? Yes, it absolutely does help me find a. A is equal to is 2 over b. So a is equal to 1 or a is equal to minus 1. So what's my complex numbers? Z is equal to a plus bi. So z is equal to 1 plus 2i. Or z is equal to minus 1 minus 2i. Okay, so a lot of questions, long video, but hopefully it has been useful. Even if you were to just take down every question in it, watch it again, slowly go through it, and then go through the practice questions, I'm sure it's going to be of some help to you.